Hello, everybody. How's it going? Welcome back again to our live virtual classrooms. All week this week, we've been talking about microplastic, how it's, or what it is, where it's found, how it's impacting sharks, and all of that. We've been partnered up with Costa all week to bring you the microplastic content. Costa has been one of our longest running partners. They've helped fund our research around the world. So a huge thank you to Costa for allowing us to put on presentations like this. And a huge thank you to our guests today, Education Ambassador Jen Cotton and Wildlife Conservation Society veterinarian Dr. Harley Newton. These guys were here on, these ladies, I should say, were here on Tuesday with an awesome class for grades K through 6. Today is grades 7 through 12. So welcome back, guys. Thank you very much. How was your week so far?
Been a lot of fun. Always enjoyable hosting these classes, so I'm very excited to be here today.
Yep, been having a great time. Thanks for having me again.
Awesome. Well, we're definitely glad to have you guys. Just so you guys know, Jen has been an education ambassador for about, 5 years now?
Yeah, give or take.
And she's come out on expeditions with us before. She helps lead our some of our outreach events on the ship, and she's an integral part of making sure that we can put together STEM courses that are free and available for everybody online. And of course, Dr. Harley Newton is our veterinarian who's on the lift with the sharks, monitoring their health and doing some awesome studies that have to do with looking at the overall health of white sharks and other shark species. So with that, I think Jen is going to be basically leading today. So with that, Jen, I think I'll turn it over to you to get things kicked off.
All right, so welcome everybody. Thank you, John, for the introductions. Today we're going to be talking about microplastics and also discussing the 5 gyres and hit a little bit on the impact that these are, well, not a little bit, a lot of it on how the sharks that we were researching are actually impacted by these plastics. So if you could click the next slide, please. We wanted to give you guys a history of plastic just so that you can follow along and have a really strong understanding of where these plastics come from and some of the properties that these plastics have that can cause some issues for the ecosystems. So plastic really first appeared around 1907. So this is nothing new. It's been around for over 100 years, but it really started rocking and rolling in production in the 1970s. So plastic is what's called a polymer. So poly means many, mer means unit. So it's a bunch of different units of a substance together. So how they make those plastics is they'll take those long chains of polymers and add another monomer, which is a single unit, to it to give each of these plastics these different characteristics and properties. And what that does is it causes these plastics to have different densities. So they're going to, sink or float a little differently within the water column, which causes a lot of problems that we're going to show you in a little while. And it also can act sort of like a sponge and have certain toxins adhere to it, which is really what Harley's kind of looking at in the shark. So Harley, can you give us just a little introduction on the types of toxins that you're kind of looking at and maybe how you got started looking at that?
Sure. So when we started looking at microplastics, we realized that not just there was an issue with just ingesting the plastics, but it was also the fact that these plastics, because they're small, they're able to absorb or absorb and basically bioaccumulate different chemical contaminants. So the things that we're worried about are things like polychlorinated biphenyls, which come from oil and gas, or organochlorine pesticides, and then more recently perfluorinated compounds, things that are in like nonstick coatings. So those are the things that we're mostly concerned about in addition to just the plastic itself.
Awesome, thank you. So yeah, she's going to talk to you guys a lot more about her work here in a little bit, but just get you so we can follow along and give you a little introduction as we go. It's really important to look beyond just the problem of there's trash everywhere. It really goes a lot deeper within the food chain. So it's a lot of what we're going to be talking about today. So another problem is that single-use plastics really have a short lifespan if you want to look at it. So from production to being disposed of, the average lifespan, meaning the use of a water bottle, is only about 14 minutes. So when you purchase that water bottle, how long you're actually using the bottle and then disposing it's a very short amount of time. So if you're doing that multiple times a day with different water bottles, that really starts adding up. Another issue is that these plastics don't break down. They take a very long time. In fact, they take so long that we don't have accurate numbers of how long it takes. We have a lot of estimates. And most plastic is estimated to take roughly 1,000 years before it fully breaks down. And in that time frame, they will break down into smaller and smaller pieces, which we're going to be discussing with microplastics. Something like a plastic bag is about 12 years. It's estimated for it to break down. A water bottle, 450 years. These things are out here in the environment for a very long time, and they're not going away. Every single piece of plastic that's been created is still here in some way, shape, or form. So it's not something that can easily break down. Another huge issue are Mylar balloons. They have zero estimate of how long. They never go away. So the problem here is very large. And even, you know, something deemed biodegradable, like a biodegradable balloon, it still takes between 3 to 5 years for it being in the environment for it to actually go away. So it's just a very slippery slope with a lot of these items. There's a lot of things that you guys can do that we're going to share with you towards the end. So next slide, please.
Real quick, I just wanted to mention, because I forgot, a lot of you have already found it, but there is a comment section below the video. If you do have questions, please use that to ask your questions. The more on topic it is, the better chance we'll have of getting to it. If it makes sense right away, I'll interrupt whoever's doing it. But Jen, that was awesome. I had never thought about that before, that you only use the plastic water bottle for, you know, what did you say, 14 minutes? I'd never thought about that before. And like I said, we've been talking microplastics all week. That's the first time I heard about it, and it totally makes sense. So anyway, I just wanted to add that also, and about the comments. So sorry, back to you.
Okay. Yeah, I know at a lot of schools they'll sell like little Gatorade bottles and things like that, and the kids just use them at lunch, and then they go in the, you know, so there's a lot of things that you can do as a student as well within your schools to help. So we're going to look at, because there's a wide range of sizes when you talk plastics. The easiest one for us to see are what we're called macroplastics. So these are just large items such as water bottles, single-use utensils like plastic forks and spoons, plastic straws, candy wrappers, you know, things like that are much larger. But as they are in the environment, they're going to break down or photodegrade being out in the sun. So that polymer starts to break down and becomes really, really brittle. It's like if you had, you know, something that's dried out and you could just crumble it in your hand. That is exactly what's happening. So those tiny little pieces are starting to slowly break down. I put some images on here for you. The one on the left is a chunk of balloons that I found on my beach here. And actually right in front of it, there's actually another chunk of little plastic. This was a balloon release that somebody did in our area. And it always comes back down, and tangled all within that ribbon is, you know, sargassum seaweed. There was a couple of little pieces with like barnacles attached to it. Unfortunately, I was able to retrieve that before it caused a lot of damage to our larger species or any other organism out in the ocean. So I was able to retrieve it, but who knows what damage it could have done along the way. On the top right, those are called nurdles. Those were found on a beach in Cornwall, England. So nurdles are shipped in containers. They're used to kind of melt down and create items, you know, like cell phones and things like that we use that you can't, it's a lot easier to ship tiny little plastic areas in these larger pieces. And they'll spill out of shipping containers pretty often. You can actually go on what's called a nurdle hunt, and you can find them a lot of times all over the beaches. I've seen them before and picked them up. Harley, you referred to them as mermaid tears on Tuesday. And when it took me a minute, I was like, oh yeah, those are the nurdles that you were discussing. And then the bottom right there, that's just right along where the waves are coming in at Cocoa Beach, which is around where I live. That is the norm. Anytime I walk along the beach, that is what I see. So we try and pick it up, but it's very difficult to actually retrieve all of those tiny pieces of plastic. So Harley, can you tell us some things that you may have seen on expedition that can kind of elaborate on this issue?
Sure. I mean, I'm going to share some images later. You know, for the most part, with the white sharks, we've mostly been focused on the microplastics, but certainly around the ship all the time, we see floating plastic bottles and, you know, milk jugs and balloons, and we do actually put in a lot of effort in going and collecting those items to get them out of the ocean.
Yeah, every time I've been out in the water, I've seen very similar items. Milk jugs a lot, and water jugs, and definitely balloons every single time. There's never been a time where I haven't seen a balloon out there. So next slide, please. So we've kind of touched on this a little bit, but we wanted to show you some other images to show you where some of these things can be found in the ocean, because it's quite appalling, the depths and the reaches that these plastics have had. So the bottle smack in the middle is something that was collected on an expedition. It was floating along, and you can see all of the life that has grown on that water bottle. So it's been out at sea long enough for that many critters to kind of foul on top of it and create a little habitat there on that water bottle. So that's shows you that hasn't broken down. That water bottle still maintained its entire shape the entire time it's been out there, and long enough for those critters to foul on it. I'm going to save the top two for last, because they're, to me, the most interesting and kind of mind-blowing. That bottom left image, that's another shot of those nurdles that were collected. So you can see how many in a very short amount of time that were collected. Bottom right, again, there's Cocoa Beach, and you could just see that line just keeps going. Anywhere those waves stop, you're going to see microplastics. So whether it's the low tide line or the high tide line, it's just littered with microplastics. The larger items tend to be up by the high tide line that you can find if you were ever interested in going and doing cleanup, which we highly recommend and we'll discuss later. So the last two images here are the ones that kind of really shocked me when I saw them. The one on the top left, that's at the bottom of Mariana's Trench, which is one of the deepest parts of the ocean, littered with trash. So there's plastic all down at the bottom. And then on the top right, that was a sample taken from Antarctica. So an area that has very little human interaction still is susceptible to microplastic and plastic pollution. So the problem with this is we were discussing some of those properties of these plastics, and their densities are all different, and it allows for them to float or sink within the ocean. So they're found within the entire water column. So it's not just a top level issue, it's from the top all the way down. So Harley, can you tell us some of the places that you've been on expedition or in any of your studies, and the amounts that you have seen in those areas?
Yeah, I mean, with OCEARCH, I've kind of been all along the Atlantic coast, which has been great everywhere from Nova Scotia all the way down through Florida. And I would say, the density of plastics, unfortunately, is pretty equal everywhere. I also spent a lot of time in the summer with my own job with the New York Aquarium in the mid-Atlantic region, so off of New York. And we do see a lot of plastic contamination there.
Okay, thank you. We're going to look a little bit on the next slide at gyres and ocean currents. So this plastic doesn't just make its way into the sea and stay put. It moves all around with a system of currents all throughout the ocean, and then they end up getting trapped in these large areas called gyres, which we're going to look at. So currents really are just this continuous movement of water. They can be generated by many different forces, like most notably would be wind, gravity, and density changes in the water. So if you have, fresh versus salty mixing together, you're going to create a current, or different temperature changes. So these different densities of water can drive these currents as well. A great deal of them are wind driven though, so they're up on the surface level. There are deep sea currents as well that are going to be driven a little bit more by density, but we're going to look a lot more at those top layer currents that are moving along. So where we live, there's an inlet, and if you are in that area where that fresh water is meeting that salty water, there's a really strong current that's going to pull you out. So that density change is a lot greater depending on where you're at. So we have what's called a gyre, which is a large system of these circular currents. So these gyres are massive. There's 5 of them. We're going to look at the one in the North Pacific because that is one of the most famous ones for a very sad reason. And gyres are really what we consider the ocean conveyor belt. So they're moving things around and really circulating all that water around the planet. And that helps distribute heat, it helps organisms, it helps, distribute nutrients all around. So they're very important systems. Next slide, please. So this is something that a lot of you may have heard of in the past, which is the Great Pacific Garbage Patch. It's one of the more popular things when you're talking about pollution as far as the marine sciences go. There's, a ton of cartoon specials my third grader has seen on it, so it's a pretty famous area in the world. So there's a couple of misconceptions with this and some things that, I wanted to throw at you to just really make you understand the issue that's going on here. Plastic in this area is 6 times more prevalent than the zooplankton that lives there. So the little tiny bottom of the food chain is being outnumbered 6 times by plastics in this area. So they're all accumulating in these gyres, and it's becoming an issue to where the food chain is really just disrupted. There are an estimated 1.8 trillion pieces of trash that's out there, and 92% of it are going to be these large plastics that are eventually going to break down, and then they will eventually go down into microplastics, which I forgot to say on the first slide, they're about under 5 millimeters, so just under the size of your pencil eraser. So there's a vast array of different sizes that are trapped within this area. So it's not just giant things, you can't just walk on it. Trash is constantly moving around in this area. It's floating, it's changing, it's circulating along with those currents. So it's becoming an issue to where you can't really do much about the situation. And as well as those density changes we were talking about, it's not just found floating on the top. A lot of it goes a lot deeper than that. So it's a bigger problem than what I think people realize, because it's just dispersed throughout the entire area, and it's not something that we can easily just go clean up, because we do get asked that a lot, like, why can't you just go clean it up? And that's really why. Next slide, please. So we're going to introduce these impacts on marine life. I put some direct impacts for you, and then Harley's going to go into her work on a more in-depth level. The image on the right was a little sea turtle that was a washback in my area, and you can see that on the bottom of that image, that's sargassum seaweed, which it was feeding on, but the top is all bits of plastic that was found within that little baby juvenile turtle that was washed back in the ocean. On the left, I also put another little turtle that's all tangled in those balloon strings that we were discussing. That's a massive issue, is the entanglement from those. And then in the middle is one of the more famous species when discussing plastic problems, and that's the albatross. They live in an area that is smack in the middle of the Pacific Ocean, and it is littered with trash. It's the Midway Atoll out there. And these birds feed their young, they're birds, they regurgitate what they eat to feed their young. And that's what you see there is in the bellies of most of these birds. So they're actually feeding their young all of this plastic as well. And then things like tiger sharks and other large predatory animals are actually going to eat those as well. So they're going to indirectly be ingesting a lot of this plastic. So with that, Harley, I'd like for you to discuss a little bit more specifically about sharks and the work that you're doing.
Sure. So the focus today is on microplastics, but I did want to again point out that macroplastics, so the pieces you can see, do have a significant impact on sharks, largely due to entanglement. And certainly in the marine environment, things like spent fishing line, lost gill nets, other pieces of discarded plastic can have really detrimental effects on animals. So the animal on the right is a sandbar shark that we caught last summer during just a regular survey that we were doing off of New York. This is a live animal that basically had the plastic on the left deeply embedded into its body, right sort of in front of its pectoral fins and going deep into its gills. That material on the left, we actually removed so that we could clean out that wound and give this animal a chance of maybe healing and thriving after we released it. But as much as we're going to talk about microplastics, I did want to point out that the macroplastics still have a significant impact. So if we want to go to the next slide. So microplastics can get into sharks in two ways. And probably one of the species we first really knew was impacted by microplastics were some of the filter feeders. So things like whale sharks, basking sharks, manta rays. And those animals ingest microplastics directly. So they swim at the surface, they filter feed, so they're not real discriminant feeders. And as Jen was saying, you know, a lot of the prey base that was supposed to be zooplankton has now been replaced by these little plastic particles. And in addition, that zooplankton can also ingest plastics. So they can take in plastics in a number of different ways, but, you know, directly they can just filter them out. The other method is something that we call trophic transfer. And basically what it is that these small particles are accumulated by animals low on the food web, so small fish that are then eaten by larger fish and then are eaten by larger fish and ultimately are ingested by sharks. And because these plastics really don't degrade, they just sit there in the digestive tracts of these animals and basically bioaccumulate. So you have these apex predators like the sharks that we study that are accumulating high loads of plastics because of the fish that they eat. The other challenge with that also, as we talked about in the beginning, is that these microplastics, because of their size and shape, do seem to accumulate different toxins on their surface. So it's not just that these plastics are being bioaccumulated by the fish, but the toxins as well. So that's one of the concerns that we have from a health standpoint with sharks is how are these plastics impacting them? So if we want to go to the next slide. So we're trying to answer that question, first of all, by documenting, you know, are the sharks that we're studying accumulating plastics? We know that some species already do, but we didn't have any information on white sharks. And then on top of that, we need to answer questions about whether we're seeing issues with their digestive system because of it, whether we're seeing issues because of their health because of it, and whether they're accumulating toxins. So a lot of the earlier slides that we just looked at showed, you know, whole digestive tract samples from animals, so basically animals that had passed away. Obviously, we're dealing with live animals, and the best way to assess whether there's plastics in their GI tract is to look at a fecal sample or a poop sample. So how do we get those samples? You'll see my friend Christina, she's on the right there. She has a big syringe that's hooked up to a red rubber catheter. And what we do is we insert that catheter into the cloaca or the vent of the animal and into just the very last bit of their intestinal tract. And their fecal samples are very fluid, so we're able to, if it's present, pull out a reasonable sample. So on the next slide, I have a little bit of anatomy since this is kind of an older class. This is a photo from a necropsy or an animal autopsy that I did last summer on a wild thresher shark that was found dead on a beach. And I just wanted to kind of orient you to some of the anatomy of a shark, and then I'll show you where we're getting these samples from. So just like the anatomy you probably studied in humans and other animals, you can see the heart on the right there, and then they have a very large liver. The stomach's at the bottom there, and that kind of red-brown organ right above that is the spleen. And then the final part that we're looking at there, the spiral intestine, that's where we are getting the fecal samples from. So we're inserting that tube through the vent and then up into there to collect the fecal samples. So we can go to the next slide. So there's a couple different things that we can do with those samples. So basically we collect them on the ship, we put them in a tube as you see in the top there, and then we freeze them and we look at them later. There's a couple different ways we can do that. The photo on the left are what we call direct smears or wet preps. So basically we take a teeny tiny amount of that fecal sample, we get it a little more wet with saline, we put it on a slide, and I just put it right on a microscope and I basically scan through it. The challenge with that, as you can see from all the brown discoloration there, is there's still a lot of organic material there. And these plastics are very, very small, so it can be really hard to actually see them. So what we do after that, you know, we can find big particles that way, but not the small stuff that we're often interested in. So what you see on the right there is a filter paper. So what we do is we'll take the fecal sample and we will digest all of the organic matter out of it. using a high concentration peroxide solution, and we incubate them for between 5 and 7 days at high heat. And then basically we dilute them with saline, and then we run them through a filter, and everything that collects on the filter we can then dry and then look at under a microscope. So if you want to go to the next slide. So these are some actual results from animals that you may know. I think the interesting thing here is they also come from all along the Atlantic coast and across all age classes. So what you see on the left is a black fiber that we found in the fecal sample from Helena, who was an adult female white shark that we collected during the NASFA expedition. The animal in the middle is Vimy, who we just sampled this past October in Nova Scotia. And he had a lot of sort of these magenta small fibers in his fecal samples. And then finally, Mission was a young of the year animal that we collected in the mid-Atlantic, and he had this blue fiber that you're seeing there. So if you want to go to the next slide, so what do we know? We've looked at 15 animals as part of the North Atlantic white shark study. They were 7 young of year. We had 6 large juvenile or subadult animals, and then 3 adult animals. And all of them had these plastic fragments in their fecal sample. So there wasn't a single fecal sample that we've looked at to date that didn't have those fragments. They were typically small fragments, closer to like a millimeter, and they were typically heavily frayed. So they were really degraded. So we knew they'd been in their digestive tract for a long time. The color types that we most frequently saw were the black fibers, followed by blue, and then more rarely red or magenta. The magenta and blue ones are typically made of polypropylene. Black are typically ethylene, propylene, or polyacrylamide. So as far as what the impacts of microplastics on sharks, that's really the next stage of our investigation. So if you want to go to the next slide, that's really one of the questions we still need to answer. So one of the first things we need to answer is, like, what is the actual identification of those fibers that we're pulling out? We do that with spectroscopy. It's something called Fourier transform infrared spectroscopy, or FTIR. So basically, those little plastic pieces, we expose to different wavelengths of infrared light, and then that instrument measures which wavelengths are absorbed. Then there's a computer that can take that raw absorption data, and it conducts some mathematical calculations known as the Fourier transform, and basically it generates this absorbance spectrum. Those absorbance spectrums are unique to different types of plastics. So that's how we will figure out what those plastics actually are. On top of that, we have a toxicologist who will be speaking next week, who studies the actual toxins that are present in the tissues from these animals. So we should be able to link up what the plastics are that we're pulling out of the fecal sample, figure out where they are coming from, and then also if that's leading to these animals to accumulating toxins. On top of that, when I collect samples from these animals and look at them, I'm interested in their health. So we're interested in doing a population health assessment. And what we do is basically the same stuff that happens to your dog or cat when they go to the vet, or even when you go to the doctor, which is just looking at all your different blood values to see if you're healthy. So the goal of this project is to link up these microplastics with the potential toxins, and then whether or not the animals are healthy, and see if they're having impacts. So we can go to the next slide, which I think is Jen.
So now that you guys have all this information, we always like to throw in a little activity that you can do to work along with us as a citizen scientist. And we're going to introduce something that is a really important piece of what we're doing, and it's part of COSTA's mission, who's our partner for this week and our sponsor. So, John, if you can go ahead and play the video really quick.
Yep, stand by.
So while John's getting that started, COSTA and OCEARCH have partnered together with the Kick Plastic campaign. So this video is going to tell you a little bit more about that, and then we're going to go over some things that you can do to help kick plastic.
Got it. They're coming back to the ship. Saw this gannet there, looked pretty funny. Wings were back and kind of out, looked funny. I think it hasn't eaten for a while because this was cutting off its mouth from any food going in. This is mono, just your basic fishing line. It's even more reason why we need to kick plastic. That's just one bird that we're seeing. How many others are being affected by not being responsible, throwing your fishing line away, throwing your plastic away.
So as you can see, this issue goes beyond just a plastic water bottle. You can be a responsible angler as well. So that was just fishing line that was stuck on a bird. And I can't tell you the amount of times I've seen that in my local area where we've had to kind of help birds get free of that because they can't fly. I've had one where a pelican was hooked from its wing to its body and it couldn't even move its wings. So it becomes a really big issue as far as fishing gear too. So you should be a responsible angler as well, which I think we're getting into in a few weeks with our responsible fishing stuff. So something that we created and JU has, Jacksonville University is one of our sponsors, has adopted as well with their summer program, the 500-step project. This is something that I do with my kids every single year, and it is one of their favorite things to do. And it was actually created by one of my kids for a scholarship opportunity. So 500 steps to make a difference. 1,000 steps is about a mile. So this is about a half-mile journey that you can take. It takes about less than 10 minutes to do. And you just go out in your area and pick up as much debris as you can find. So any kind of pollution, debris, plastics, whether it is a plastic bag to a water bottle, all the way down to those teeny tiny degraded down pieces of plastic. Get out into your local community and do those 500 steps to help make a difference. So get out there, pick up that trash, and you'll be helped by not allowing it to move into our waterways. So no matter where you are, this is an impact because even if you're in the middle of the United States landlocked, all of that will eventually make its way down to some kind of body of water. So this isn't just an ocean problem, it's a freshwater river, streams, our estuaries, our intercoastal, all of those areas are all impacted by this. So we challenge you to get out there, go do those 500 steps, get some fresh air during the quarantine, and walk around your neighborhood and see what difference you can make.
So that kind of, you may, just to reiterate, you may have just answered a question that somebody had. So what can you do if you don't live near the ocean, Riley, who just asked that question? Like Jen said, I never would have thought of that. You can, since kind of all roads lead to the ocean, anything you can get up off the ground, any debris. That's kind of what you're saying, Jen, is even if you're not anywhere near the coastline, you can still contribute with the 500-step project, right?
Yeah, any body of water you're around will eventually work its way down. So if you look at a map, I wish I had one that I put in here, but if you look at a map of, the United States in general, it's all kind of like all these little veins of freshwater systems, and it will eventually all drain back down to the ocean. We discussed this a lot when we did dead zones the very, very first week. We were talking about how fertilizers and runoff makes its way down to the Gulf of Mexico. It's the same idea with plastics. It all eventually works its way down. The Great Lakes, too, they are a really important ecosystem for a lot of organisms, and they're covered in plastic. So even if you live, in Chicago or all those really high up north areas, that's an area that you can work as well. Goes beyond the ocean. So with that, I'll open it up to any questions that anybody might have. Yeah,
there were some good ones. You just took care of that one for Riley about not living near the ocean. But one, I guess Riley has another question that he asked earlier on. Why are animals eating the plastic? I mean,
so there's lots of reasons. The macroplastics can look like normal food items. I mean, when you talk about sea turtles, a lot of sea turtles, a big part of their diet is jellyfish. If you think about what a floating plastic bag or a floating piece of balloon is going to look like on the ocean surface, it's going to look just like a natural prey item. So that's one of the reasons they eat them. And as far as the microplastics go, For smaller organisms like the zooplankton, they have the same issue. Those white floating microplastics look just like food for them, so they eat those. Filter feeders, because they're indiscriminate, they're just passing water over, into their digestive tract and filtering food out, they're just going to pick up these particles. And then for sharks, it really is kind of incidental, particularly sharks that are mostly eating, fish. There's already just plastic inside the fish in their GI tracts, and that's how they wind up eating them.
Which is a perfect segue to another really great question asked by Michaela, having to do with, well, obviously humans eat fish too. So if you're, having your favorite seafood dish, are you potentially eating plastic also, just like the shark is?
So, most, seafood items that you're eating, they pull out the intestinal tract. But what we're learning about, plastics is you have your macroplastics, you can see, you have your microplastics that you can sort of pick up on a microscope, but now we have even smaller fragments that are called nanoplastics. And these are the ones that we really don't know a lot about yet, but they do seem to be able to get into cellular membranes. So it's entirely possible that, getting plastic into the food web can be down to a cellular level.
And that's something I think we're going to hit on a lot more next week with Lisa Crawford as well. So we'll go into all the toxicology of this and the different chemicals that they're seeing within the muscle of the organisms, which is what we're actually eating. So that's something that you can definitely stay tuned next week when we have Lisa on, and she can hopefully go into a lot more detail on that as well.
I don't know if either of you will know the answer to this question, but is there such a thing as good plastic that you're aware of? I don't know the answer to that, but maybe one of you do.
Well, there's certainly plastics that are not single use, right? So, I'm not going to say that they're good plastics, but they're definitely better plastics. So they're ones that you're going to keep around your house the same way that you would, use, glass or other items. So it's really the single-use plastics, the disposable plastics, that are of the greatest concern here. So I wouldn't say that they're good plastics, and I think in many ways we've started making better plastics, things with stabilizers that don't have things that we now know can leach out and be toxic. So yeah, it's the single-use plastics we're most concerned about.
So something I tell my kids, something like a Yeti cup, that top part is still plastic, right? But if you're using that cup every single day instead of using a water bottle, that's 365 single-use water bottles that you are not putting into the environment. So I think a lot of misconception with cutting back on plastic is that it's one or the other. You're either using it or you're not. And it's just more about being responsible, like Harley was saying, and cutting back on those single-use plastics. So I wouldn't Harley classify it as good, but there's definitely a much better alternative to where you can make an impact by using something that is reusable. So, think about a trip to the grocery store, how many plastic bags you're using, replacing that with a thing like a tote or even a reusable bag that has plastic material in it, you're still cutting back on all of those plastic bags. So that reduction piece and reduce, reuse, recycle, that's the key for kicking back on all of this. So, I mean, it's not end all be all. I don't think it's feasible for us as a society to completely cut plastics out. It's in medical equipment, it's in all kinds of stuff. But just being a lot more responsible about your specific usage, I think, is key for all of this.
Excellent. And maybe, Jen, this question's for you. I think maybe for somebody who may have missed it, but can you just really quickly explain what a gyre is again, since it's the title of the whole thing, just as simply as you can?
So essentially, it's a circular current moving through the ocean that's wind driven. So it's consistently there, and it's just a giant circle essentially of a current that's pushing things throughout the ocean. They're really important for heat distribution and maintaining, the ocean as a whole. So, I mean, that's essentially what they are.
And then I think maybe this person missed it too, but how about you did answer it, but I would be curious to hear it again because I haven't heard the numbers that you said, and I think it varied, but how long does it take for plastic to break down again?
Depends on what the item is. In general, the estimate for just plastic as a whole, like 1,000 years is our estimate. We don't really have a complete end-all be-all, this is the number. A water bottle, which is one of the easiest things to cut back on, 450 years. So that's how long it is floating out there. So it really varies between, you know, anywhere from 12 years of a plastic bag all the way up to 1,000 years for just general plastic. It's not a quick process. So I guess that's the big takeaway from that.
Cool. I think that takes care of most of the questions. Did you guys have anything else that you wanted to add? I mean, we've been talking microplastics all week, but just having the two of you in this presentation, I actually learned a couple of things that maybe I probably should have known, but I really appreciate you two. Do you have anything else to add before we sign off here?
I think just one message as far as, and I already kind of touched on it, but don't think that you have to go through your whole house and completely get rid of everything and make all the changes at one time. That's something that I noticed just in society when people start talking about, like, let's cut back on plastic straws, let's ban grocery bags. These are all small changes, and for every small change you make, you're chipping away at part of this problem. And think about if every single person decided to use a reusable cup versus a water bottle. That problem is just going to be really just chipped away. So don't try and overwhelm yourself with thinking you have to replace all of the things in your house at one time. Slowly work through the products, slowly start making those small changes. And that's really how you as an individual can help us work towards fixing this issue as a whole. And in turn, you know, the work that Harley's doing, hopefully she will eventually see an impact on, you know, this reduction in the species in the ocean.
Yeah, and I would definitely sort of second what Jen said, which is like the smallest things that you do each day, like even if every time you go on a walk, you just pick up the plastic and keep it from getting in a waterway, you know, that makes a huge difference. So it's definitely something worth doing. Don't overwhelm yourself, but even the tiniest things have the biggest impact. You know, and for me, I just wanted to say thank you to OCEARCH and everybody for this week. You know, obviously my research is heavily impacted by OCEARCH providing access to these animals, and I'm just really glad I could share this all with you. So thank you for that.
Yeah, thank you both for all of your hard work. It's always a pleasure having both of you on. Jen, you're on a little bit more often. Harley, certainly, as in case you guys haven't noticed, and I'm sure there's going to be some people who get upset about me when I say this, but in case you didn't notice, Harley is usually the smartest person on the ship. We have a lot of smart people, but Harley, it's always great to have you. So thank you very much. Thank you, everybody who joined today's class. Keep an eye out for more of these classes on all of our social media channels. We have some awesome classes next week having to do with toxicology. It's sort of like they kind of hinted at one of the next steps, finding out, you know, what kind of toxins are in sharks, not just plastics. So stay tuned for details on that on all of our social media pages. Thanks to Costa again for being with us all week to put on these classes. If you guys have any questions, you can always reach us at education@ocearch.org. Send us an email and we will jump on it and help however you can. Jen, Harley, thanks again. And with that, I think we'll sign off.
Thank you, guys.